to the deep dive. Today, we are pulling back the curtain, really getting into what makes an AI platform go.
Not just what it does, but the engine behind it.
Exactly. We're diving deep into that core technology stack,
Yeah.
the hardware, the software, the actual strategies powering these modern AI platforms.
That's right. And the sources we've got today are pretty technical, actual documents, hardware recommendations, architecture diagrams, deployment plans. It's the real nuts and bolts.
Right, the foundational stuff. So our mission here is to kind of translate this, to pull out the essentials, cut the jargon, and really highlight what's crucial for you to understand, especially if you're looking at this from, say, an investment perspective, evaluating its potential. What's in this engine room and why should you actually care?
Because these choices, these technical details, they aren't just academic. They directly impact, well, everything. Performance, how fast it feels. Scalability, can it grow? Efficiency, what does it cost to run? These are absolutely critical factors when you're trying to assess the strength, the real viability of a business built on this tech.
Okay, let's really unpack this then. Starting in that engine room, you've got to begin with the actual physical stuff, right? The hardware. What makes this platform tick?
Think of it like the power plant and the assembly lines. The sources break down several key hardware types, each doing a specific job. Now, for the really heavy lifting, the AI stuff.
Running the models themselves.
Exactly. Especially what's called inference, basically, when the AI is actively using its training to give an answer or make a prediction. For that, you need serious graphics power, GPU inference servers.
So these are those specialized chips, like the ones NVIDIA makes.
Precisely. The sources point to things like NVIDIA A100s or A10Gs. You find these in cloud setups like AWS G5 instances or Google's A2, or even dedicated boxes on site like an NVIDIA DGX station if you need that local power.
And why does that matter for, say, an evaluator?
Simple. The number and type of these GPUs directly limit how fast the AI responds and how many users it can serve simultaneously. It's a huge factor in perceived speed and the platform's ability to handle AI workloads. Big cost driver, too.
Got it. GPUs are the AI muscle, but the platform's got to do more than just AI, right? There's other stuff happening.
Absolutely. You need general compute power for, well, everything else. Running the platform's internal logic, coordinating different tasks, processing data that isn't strictly AI. That's where CPU compute nodes come in. Standard, powerful servers.
Like running the website backend, managing workflows, connecting to other apps.
Exactly that. All the coordination around the AI. The sources mention cloud instances like AWS C5 or C6i using Intel Xeon chips or GCP's N2 with AMD EPYC. For you, the evaluator, knowing these are sized right means the platform can handle user traffic, manage its own operations smoothly. It's the baseline responsiveness.
Okay. And the sources also mention something called edge devices. Why would an AI platform need hardware physically out somewhere remote?
Yeah, this adds a layer of versatility. Edge devices let the platform do some processing locally, right, where the data is generated or where an action needs to happen fast without needing a perfect connection back to the main cloud servers all the time.
Like analyzing video from a drone right on the drone itself.
Exactly. Or processing sensor data on a farm, maybe running a security probe inside a client's network, even if it's temporarily offline. It extends the platform's reach.
What kind of hardware are we talking about there? Tiny computers?
Pretty much. Things like a Raspberry Pi 4 with a specialized AI chip, like Google's Coral TPU, or maybe an NVIDIA Jetson Nano or Xavier NX. Small but capable. For you, seeing an edge strategy means the platform isn't just cloud-bound. It can tackle problems in different environments, potentially opening up new markets.
Okay, so you've got hardware in the cloud, maybe on-premise, out at the edge. How does it all talk to each other reliably? That seems crucial.
It absolutely is. Reliable, low-latency networking connectivity is non-negotiable, especially for those edge scenarios or distributed teams. The sources emphasize robust networking, sometimes even using creative solutions.
Like satellite internet for remote places.
Yeah, exactly. Examples like using Starlink for connectivity where fiber isn't available, coupled with solid internal gear like YubiQ Unify. From an evaluation view, good networking isn't just a detail. It's fundamental to uptime and performance, especially if the platform relies on real-time data or distributed components.
Okay, compute power, check. Network, check. Where does all the data live? The information the platform uses and creates.
Right, data storage. It's not just one place. You need different kinds. For huge amounts of raw, unstructured stuff, think images, video feeds, raw logs, you need storage and data lakes. This is also where the trained AI models themselves might be stored, and backups too.
Like Amazon S3 or Google Cloud Storage.
Exactly. Those are common examples for cloud. If you need it on-premise, maybe a network-attached storage device, a NAS, like something from Synology.
And what about the more structured data, user details, workflow steps, that kind of thing?
That goes into database servers. For the core relational data user accounts, lead status,
Hmm.
the steps in an automation of standard relational database is the way to go. The sources lean towards using managed services here.
Managed, like Planet Scale or Supabase. Why is that significant?
Good question. For you, the evaluator, choosing managed services is often about speed and efficiency. The cloud provider handles patching, backups, scaling to a large extent. It means less operational overhead for the team running the platform. They can focus elsewhere.
But not always managed.
Right. The sources note that for really strict compliance, maybe in finance or healthcare, you might need an on-premise database, like Postgres running on dedicated hardware, maybe a Dell server. So you might see a hybrid approach which shows adaptability to different regulations.
Okay, so the data is stored. How does the platform feel quick and responsive and manage lots of simultaneous tasks, like those automations?
That's where caching and message queues become vital. Caching, often using something like Redis, maybe AWS Elasticache Redis, acts as a super fast temporary memory for data that's needed often, like user session info. Speeds things right up.
And message queues.
Think of them as organizers for tasks that don't need to happen instantly. Instead of trying to run 50 automation jobs at the exact same second, you put them in a queue. Technologies like RabbitMQ or maybe BullMQ on Redis manage this
So it smooths out the load.
precisely. It prevents the system from getting swamped and ensures background tasks like those automations or security scans get done reliably. For you, seeing this means the platform is built to handle load gracefully and execute background work effectively.
With all these moving parts, security must be a huge concern. What hardware helps lock things down?
Absolutely critical. Security appliances are essential. We're talking network firewalls like Palo Alto Networks, Fortinet acting as the main gatekeepers for network traffic, and web application firewalls or WAFs, often a service like Cloudflare protecting the actual web dashboards and APIs from common online attacks.
So multiple layers of defense.
Yes. For you, these aren't optional extras. They build trust, protect data, and are often required for compliance. A serious platform invests here.
And how does the team know if everything's actually running okay or if something's broken?
Visibility is key. That's monitoring and logging. Tools like Prometheus collecting real-time metrics, CPU load, memory usage, network traffic visualized in something like Grafana, and systems like the ELK stack, Elasticsearch, Logstash, Kibana gather all the system logs.
So they can see errors, track performance.
Exactly. For an evaluator, having robust monitoring shows operational maturity. The team can spot problems, optimize, understand what's happening inside the black box.
And finally, just in case disaster strikes.
You need backup and disaster recovery. Automated processes. The forces mentioned database snapshots, replicating data to different physical locations, archival backups to cloud storage vaults, or even tape disk for long-term retention. This ensures business continuity and meets compliance needs. It's the safety net. So just to wrap up the hardware bit for you, the evaluator. Understanding these pieces, the GPUs for AI, CPUs for general tasks, edge devices for reach, the network, the different storage types, databases, caches, queues, security, monitoring, backups, it gives you a real sense of the infrastructure investment. It shows how the platform is built for speed, reliability, and growth. It's the physical reality underpinning the business.
That's a really clear picture of the physical foundation. Okay, so we got the hardware, the muscle. Now let's shift to the software, the brains, the nervous system. How is it all structured?